Hi guys, my name is Mike Colson. I am EUC Juggernaut with Solidfire. I made up that title. I'm waiting for one more approval. Hopefully I can get it and so it shows up on my W-2. Today we're going to talk about EUC Storytime. So if you guys aren't familiar with what Solidfire does, hopefully you're going to get some of that out of this, as well as some of where we see the market going from an industry perspective, where EUC is going from a maturity perspective, and how we tie into it. So, the Hermit, the database, and the mixed workload. The Hermit had to live alone. The Hermit was somebody who is a lot like VDI in the traditional data center, right? It had to be put aside and not mixed with its play friends within production environments. It's because the Hermit was told it was special. The Hermit was told it was a special little snowflake. Who here likes to manage special little snowflakes in their data center? Not a goddamn one of you is who wants to manage a special snowflake in the data center. And if you think about it, at the end of the day, the snowflake falls down. It can become a regular snowman like any other piece of snow, or it can become a muddy mess if it's not properly implemented. This snowflake was told it was different because it's an onion, like Shrek. It's got many layers, right? And we've added to it over time. So what was VDI originally is no longer the end result of what we're trying to get to with EUC. It's grown over time and added things which initially I think none of us thought really made sense. MDM, when we were like, oh, well, mobile device management, we're like, well, have you ever used the Horizon client on an iPhone? It's awful. But it's gotten better, right, as time's moved on. DAS kind of sits out as the lone pimple on the ass of what EUC is. It kind of remained a special snowflake for a while. I think you saw today when Ken was talking that started to migrate in. We're starting to see that even DAS through a hybrid approach is going to be better suited to the way we look at and manage data centers. And not surprisingly, DAS is a space where mixed workload happens all the time. So because EUC was different, it was forced to live out in its own little island of its own infrastructure, its own storage set. If you look at most best practices and most white papers and most reference architectures, do they say, hey, put this next to Exchange, put this next to your production database environments? Yeah, no. I see you shaking your head. It's okay, you guys can talk back, it's fine. We're all in this together. Databases, though, and production workloads, they grow strong in this environment, right? They like that they have the production workloads and all the production money to go with it. They can continue to grow. And we all know the app owners and the DBAs are the ones who are funneling the money into their projects. And from an EUC perspective, we're always like, hey, wait, you want better user performance and experience, you need to give us some funds too, so we don't have to live in this little rowboat that you've given us. Databases consume everything that they can. Just like Starkiller Base sucking in the suns around it, they are there to destroy us. No, maybe not. This might be a little far. But they are going to take everything they can, and how do we protect our environments and how do we manage it? Well, the Hermit's kind of given us a roadmap now. The Hermit said, hey, at some point you're going to want to come around and find me. Some point EUC is going to become a production and a mainstream workflow. Some point you're going to realize that we're not a redheaded bastard child that's sitting in the back room. We belong as part of a true tier 1 production workload. So I'm really into value chain mapping. I don't know if you guys know who Simon Wardley is, but the Wardley mapping methodology for looking at maturity and lifecycle growth of any technology within a subset of our industry. But it looks at value to the end user or value to a business, and then measures it across the genesis of that product as it evolves over time. So what we started off with was personal computing. Right? Oh, hey, look, we're decoupling from mainframes, and we now have desktops and laptops. Great. As we moved through that evolution, we came to realize we needed to be able to access our resources and applications. Because at the end of the day, if you look at that top right, we need data access. Right? That's what Workspace ONE's about. We want to have access to our apps and our data as fast as possible. What is the desktop but a launch pad for access to our applications? It's almost pointless. So as technology evolves and we move up the stack from virtualization up into this SaaS and DaaS platform, we have to move with it from an infrastructure mindset. We have to get away from thinking, well, it's just this little program that runs on the side. Because it's already evolved. We're already at the point where we have DaaS. We're already at the point where we have SaaS, and we're starting to see cloud adoption. The Hermit's already made that jump. If you guys were paying attention at all to some of what they're talking about, these models are starting to become a hybrid approach, right? And what we're doing within cloud spaces across the industry, we're starting to see that happening on-prem as well. We're starting to see folks realize that, hey, shared workload environments and software-defined data centers where we're driving the production environments to be automated and work together, that's already happening, right? In every other facet. Why not EUC? And the stack kind of builds on that too. So we've gone beyond just having compute and virtual desktops. We have UEM, we have profiles, we have apps that have to sit on top of it. And AppVols really kind of changes the game in the way that we approach this, especially from a storage perspective, because app volumes gives us something we actually have to worry about. It's not just another thin app file. And if you guys are familiar at all with the versioning, who here uses AppVols at all today? Wow. All right, who here uses Citrix like XenApp today? A couple of you. Who here is doing any application publication to their customer, their end user? All right. So if we're not just looking at AppVols, we look at everything. There's a genesis that happens, right? AppVols is the VMware approach to that, along with RDSH. They have readable and writable. Readable is cool. Readable is just another application that I've bundled and isolated within an environment, and I can spawn it and map it. Awesome, great, cool in a way. The way UEM is going to change, user environment management, with writable AppVols, is going to allow us to map those user profiles directly to a disk and really accelerate the time to value within our desktop environments. Because now we don't have to worry about another profile management tool. We don't have to worry about another way of tying in that app data. We can just allow them to write to the volume. And users, like our biggest push back in an EUC environment is, hey, I have my laptop already, I can do this. Well, we can push applications down to the desktops using AppVols. We can tie those profiles across. We can do a lot of different things, and writable AppVols are going to be a lot of what's going to change that. So the Hermit's realized now that he can live amongst the people. So he's going to extend himself out and say, hey, come on in, let's play. We need to figure out how we play together and how we work through mutual existence. The traditional architectures and the way that they approach things, they had separate storage infrastructure and separate EUC infrastructure. That's what I keep harping on, right? Different hosts, different VMs running, but that storage piece is what drives the cost up, because storage is one of the most expensive things you can have in your data center. With an agile architecture, something like what Solidfire can provide, we can have all of this together, incorporated within the same structure, and ensuring mutual performance and guaranteed qualities of service to all of those applications running side by side. You know what, we're just gonna skip that because we don't have a whole lot of time. So the way this works, right, is in our mixed workload environments, we do performance-based guarantees on IOPS at every volume level, right? So as volumes get created, we set min, max, and burst. We're really the only ones that are playing in that minimum space. Minimum means that you're never, ever going to drop below this threshold of performance, which, if you think about it, that eliminates a lot of that noisy neighbor thing, where I'm adding another workload in, and it's going to start spiking, especially in an IO storm. And what happens here, if it's just max limit, this spikes up, this is going to have to drop down, right? It's not going to be able to maintain that steady flow. Well, as we look at it from this perspective, if you're running steady at, say, 8,000 IOPS, and you have a IO burst on another workload, we're guaranteeing that 8,000 IOPS at the minimum. Boom, you just keep moving along, and when this comes back down, the whole box or the whole cluster evens back out. So we come at EUC with a slightly different approach. We have highly scalable workloads, right? We start off with 4 clusters. We can add individual 1U nodes into a cluster and continue to scale, because scaling is important. If you think about, if it starts with a P, it's going to end up in production, POC, pilot, production. That's how it goes. Same thing all the way through. The guaranteed performance, mixed workload, or multiple pools. And then we look at it from storage efficiency. So, you know, it's table stakes of dedupe, compression. This is globally applied, not just per dual controller set within an array. And we're not the only ones who think this is a good idea. So VMware actually had a blog post up, and they said, you know, Solidfire AI and virtual infrastructure is kind of the intelligent way to consolidate mission-critical workloads. EUC is a mission-critical workload. You can scale performance or capacity independently, so you start off with those 4 nodes. As you need to add more workload, more desktops, or just different workloads to an environment, you add a node. You need to scale performance because you need higher CPU, lower latency. Yeah, we can do that, just add a node. It's just a matter of adding those incrementally as you go, so your cost of entry is much lower than going out and buying traditional storage architectures. The reliability is there, right? So this is all self-healing solution. If a single node fails, data is automatically redirected. It has a to write across the entire cluster. We're not doing any RAID, right? Because we're all flash, so doing RAID it's like fighting with a lightsaber incorrectly. Like, I don't know what the hell I'm doing, and that's how you end up losing an arm initially. Sorry, that's another Star Wars joke. It's self-healing. There's no damage to any of the data. Everything's written across. And from a performance control perspective, if you think about as you add different types of desktop workloads in, you have to worry about how I/O is controlled. Each one of those could sit on different volumes, and those volumes would then each control that minimum, maximum burst IOP capability. And you can control all of that real time. You can make those adjustments, right, on the fly as you see need. We have best practices, but if you start seeing a requirement for more IOPS within a specific workload, you can just bump it up. Think about it this way, like backup windows are a pain in the ass to try to meet, right? If you have your backups running and you have cron jobs within a certain data set, and those servers need to be able to bump up IOPS, they have the burst capability, but we can also just make through API, drive the minimum IOPS up during that backup window and achieve that job to accomplish within the time frame that you need it to happen. We're going to get to a demo, so you're going to be able to see how some of this works. So if you think about QoS, if you have an I/O storm, right, you get this massive spike all of a sudden. In that mixed workload environment, if that were to happen, every other workload within that infrastructure would just have a nosedive, right? As that one workload built up, everything else would have to take a back seat. That's rate limiting. But if you have QoS, if you have a single burp up, everything else can maintain that steady state because it's guaranteed those base IOPS. That solves 93% of our storage efficiency issues. And it's super easy. It's sliders. Like a monkey could figure this out and how I set up my limits on my volumes. In addition to that, it's all API driven. This was really built out for the cloud service provider market. So if you think about how many tasks you had to do setting up traditional storage, it was a lot, right? For us, it's a handful. You're basically setting it up, saying, okay, here's what I need from size and IOPS, and we're going to roll out with that. And I mean, it's way fast. If I used to work at another company that had 3 letters, and it was cumbersome to get some of those boxes up and off the ground initially. Here, it's really set it and forget it. It's cluster-based, it's scalable, it's really, really simple. So I mentioned before, we're not tied to dual controller setup. Everything applied is applied globally. So as we add additional nodes, we have the compression, we have the dedupe, we have thin provisioning. It's always on, it's always in line. We're not limited to the scale. We can scale up to hundreds of nodes, right? We have that ability there to continue to grow with the environment. Plus, we have the ability to scale down. So if you're over provisioned, if you only need 4 nodes and you have 5 because we had an initial thought process that you were going to require more, or you found greater efficiencies, you can actually seed data to that, pull it out, drop it in a UPS box, kick it off to another data center, put it in, add the additional nodes you would need to get to a 4-node quorum, power it up, boom, your data's on the other side, start sync, now you're DR'd. What the what? Like, come on. That's crazy. We have different nodes based off of different requirements, so everything from an entry price, great price per user, up to your max capacity. These are all mix and match, so it's like the kids wearing socks that are different colors now. If you want them to go together, they can go together. Software version doesn't really matter. You can run older firmware versions together, and they can all update, and it's a really easy process. I mean, it's kind of the simple, easy button for storage, and again, everything can sit on that same workload. It's not great for all use cases, but it works for a lot of use cases. Sample configuration, right? So think about your standard 2 vCPU, 2 gig of RAM, 50 IOP desktop, and it's 50 IOPS, either steady state or burst. I mean, we can play with it a couple different ways. Our reference architecture and best practice actually sets for up to 300 IOPS per desktop. So you can imagine, like, there's a lot you can play with within here and your sizing. So that would all fit on a 4-node 4805 with 200,000 IOPS ready and 68 T capacity. Those desktops go over there. You're looking at basically an OpEx cost of about $2 a desktop per month. And it ends up being about 3,094, 3,100 desktops within that 4-node cluster. And that's the entry-level cluster, right? So that's pretty low cost. And think of it this way, if you start looking at more workloads within that same structure, that cost goes down. The more workloads I can put on a cluster, the lower cost per desktop is, because I'm sharing that OpEx and that CapEx with the other workloads in the environment. It's not just from my EUC budget. All right, you guys want to see a demo? All right, so we have a VDI environment spun up. And I'll show you that it's actually running. Ta-da, see, desktops. You don't see desktops. All right, hold on. Inventory's coming up. I wasn't on the right screen. Ta-da, desktops. So a couple errors, but I spun it up like 10 seconds ago. There's 50 desktops running in this environment.
You don't see it.
Oh, you guys didn't. Oh, son of. That's why you were saying no. Got it. Okay. Desktops, ta-da! Try it again. All right. So within this, right, I have desktops running. Go away. I have desktops running within View, various levels. I mean, they're up and running. This is just kind of like a, hey, there's desktops. No one's logging into these. We don't really care about the domain environment. We just want the workload. You go to the cluster. I also, alongside this, have a MongoDB instance running. We can look at the performance of that MongoDB instance. Pretty decent, right? Running about 3,700 IOPS steady. And if we drill into what that looks like from the QoS configuration, it's got 3,000 IOPS as that default minimum, right? We can change that if that DBA needed more, but we're just going to let it sit for right now. The desktops, meanwhile, are running across a couple different pools within a couple different volumes within that cluster. So let's drill into one of those. Let's pick this one. Give it a second to populate. So this is just one of the volumes. We typically say about 50 desktops per volume. Not a whole lot of I/O being done in here, right? steady about 20 IOPS. There's probably only like 2 desktops in here because there's only 50 spun up. So let's go ahead and cause a little bit of IO storm. So let's grab this pool and say, let's go up to 200 desktops. We jump back, we can see vCenter is going to start kicking off the workload momentarily, because it takes a while. And we'll start to see that spike happen within those volumes, and it's already started. So we start seeing that IO storm start to hit the individual volume. Meanwhile, back at the ranch, come here, you go over there. If we look at that Mongo instance, it's continuing to stay the same, right? You see a little dip, but right there within that 3,000, and then instantly pops back up. If we say, okay, DBA's getting on our tail, they need a little bit more performance, cool, we can do that. During a boot storm, mind you, those VMs are still spinning up. We go in and we say, they're asking for 5,000 minimum IOPS now. Go back into that Mongo DB instance. It's going to start to climb up to get back to that minimum, and those desktops are going to continue to build out with that same threshold. Give it a second. Scroll over. Gotta love doing this stuff live. Come on. So desktop's still building, right? DB instance starting to spin up the workload. Hopefully, it's still spinning the workload. So it'll start to build, and there it's at 4,000, popping up and down. It's kind of a random IO on the DB right now because it's just a fake workload running on that. So all of that can be done like on the fly. On top of that, we have the ability to say, because it's all API driven, we can say, okay, well, we want to grow this and add additional volumes to our hosts and add additional volumes to what we call a volume access group, which is how we manage from a top level, like how we have access and how the IQNs are added into the storage to connect up for the data stores. If we run this script, basically it's hooking up to, it's hooking up to the Solidfire cluster, tying into vCenter, some account settings, how it ties in, some of the volume IDs that are being created. I could also create these through the same PowerShell calls, but I just had them pre-configured because I've tested this about a million times and blown it away a couple times. It was just easier to do it this way. Finds the volume access group, adds those IDs to the volume access group, grabs the cluster name from vCenter, adds the iSCSI targets from the hosts to the access group, and then creates the data store and rescans the HBAs. And yes, we're going to do this while it's doing everything else, because if it breaks, we're in a demo, so it's okay. So it starts to do the connection, adds the volume access group, pulls the iSCSI targets. Hopefully this flies. How are we on time? Oh, we're good. There it goes. So it starts to add the hosts to the target list, and then it'll go in and say, okay, we're ready for this. The volumes are added into the access group, and now we're going to start adding the data stores into the hosts. Simple, right? You guys use PowerShell for your administration? A little bit? Okay, good. We're also hooked up, so from an API perspective, the way that this is managed as you build these out within the UI, you can also see what's going on in the cluster and look at those individual API calls. The next version is going to be even slicker, where you can actually just copy paste right out of the UI and paste it into your PowerShell environment. Say, okay, run this. So you guys starting to see the value, right, of running these workloads next to each other? starting to see how this can maybe drive that cost down? All right, we'll come back to this. Let's finish up. All right, so because we can do mixed workload, because we can get rid of the conceptual idea, right, of having to run everything isolated and siloed, we've gotten rid of our split data center. We can start dropping down the price of ownership. We can start showing faster ROI, and we can start showing better performance. It's, again, all flash. We can guarantee desktop IOPS. We can scale this up and down. We can do all of the baseline things that we need to see. If you guys need to get in touch with anyone about this, right, there's a local sales team, Jesse and Joe, they're here in Minnesota. Keith Norby is local as well, but he kind of handles all of our field engineering and corporate resources. There's me, I'm on Twitter. My email is here, feel free to hit me up. There's reference architectures, Tony Packady's blog about the agile architecture and how Solidfire works within that, and you're available to mess with all that stuff. I'm gonna open it up because I wanna make sure we get some questions in. Does anyone have any questions about anything that you saw today? Do you wanna see anything else? Wow, guys, I ran through that really fast. Nobody has any questions? All right, cool. Well, I'm easy then. Thanks. You guys good? I'm good.